Well,
This meeting is being recorded.
good morning. It's a pleasure to be with you guys. And I'm really excited for what you're about to do. I've got a couple things I wanted to share with you just to kind of get you excited about the Designathons. And the general term that I use for this is crowdsourcing. So I want to talk about how it helps me because I use crowdsourcing every chance I can. And really, crowdsourcing is any time when a design team says, we're not going to do it all ourselves. And we're not even going to give it to a contractor. We're going to go out to the general public and see who's out there who has ideas that can help us in what we're doing. So you just heard a bunch of the projects that I'm on, and it's funny because I'm on some of the most exciting things that humankind has ever done. We're doing things that have never been done before, but I tend to be not satisfied. I'm like, how can we do that better? Or yes, we're doing this and no one's done this before, but is there a way we could make it bigger? Is there a way we could make it do more? Is there a way we could get more return for our investment? And those aren't the things that are going to be our current project. Those are sort of ideas where that helps me to understand what could be the project after the project that we're creating today. And kind of thinking 2 or 3 steps down the road, it's useful because it helps me to think about, okay, so what do we need to learn in the project that we're doing today? So like the rover that we're working on now, when we take it to the moon, we want to go to Mars, but we also want to expand our presence on the moon. So we want to do more than just what we're going to do with the Artemis program. So I like to think about what would that next program look like and how could we utilize the moon even more than what we're about to do. So I do that in my spare time. I don't get paid for that. That's just something because I love spacecraft design. It's just something that I can't help myself. It'll come in the middle of the night. So weekends, holidays, other people are out playing. I'm out thinking about what's the new habitat. And so the common habitat is my idea of what could be the habitat after the next habitat. So earlier this year at the aerospace conference, I presented some ideas about what that habitat might look like on the inside. And I need to give you some background just so that you can know how I needed crowdsourcing to help me. So, oops, I just hit the wrong thing. So just some background. I wanted to see what would happen if we did something like we did what NASA did. Wasn't around, well, I was a little baby then. But in the 70s, NASA took the Saturn V rocket, they took a fuel tank out of it and turned it into a habitat. So I'm thinking, what if we did the same thing with the rocket we're building now, the Space Launch System? So I looked at that propellant tank, the liquid oxygen tank, to see how could we use it as a habitat. Did a study to look at how we arrange the interior. Is it vertical? Is it horizontal? Study ended up deciding it should be horizontal. I looked at crew sizes. Should it be a crew of 4 or should it be a crew of 8? And the 8 crew horizontal worked out better to me than the other options. And again, this isn't the current program. So all the other things, that's what I do in my regular daytime. This is what I do outside of my daytime. So I did an internal architecture looking at how I'd arrange it. I looked at a 3-deck configuration. The lower deck's kind of your private deck. That's where you've got all the crew quarters, where you've got your bathrooms, pretty much the things where you want to be private by yourself. Then the mid deck is your working deck. All your hatches are here. So this is where you transfer to other elements, where you leave the spacecraft. It's also where you do your daily work, your laboratories, your maintenance area, and your exercise to stay physically fit and counteract the effects of reduced gravity. Oh, I didn't tell you one other thing about the Common Hab. I want this to be a single design that works no matter where you go in the inner solar system. So if you're in space, you can use it in microgravity, whether that's orbiting like the space station or traveling between Earth and Mars or some other location. I also want to be able to use it on the surface of Mars and on the surface of the moon. So my goal is one common design that works no matter what the gravity is. The upper deck is sort of a social deck, group deck. It's kind of the functions that you do together with other people. And I won't go into any more detail about that. That just gives you the frame of what we're talking about. Then at SIN conference, I talked about how does that common habitat fit into a broader architecture, and in particular the surface. And I won't go into detail about this, but just this shows how the habitat fits into a base camp. And there's something important to notice. You've got the habitat, which is the big structure. There are 2 logistics modules docked to it. That's what you see at the bottom and on the right side of the image. There's an airlock docked to it on the left side of the image. And in the background, you can see a pressurized rover that was just leaving. It was docked to the back side of the habitat. Now, if you zoom in, looking on the right side at the right side logistics module, there's a small cylinder connecting that module to the logistics module to the habitat. And I talked about that at Ascend also. It's a docking system. I needed a way to connect all of the different elements and came up with something I call a multi-gravity active-active mating adapter. I needed it to work no matter what the gravity is. I needed it to work whether it's the habitats, the rovers, logistics modules, anything else. But I also had a new concern.
Robert, excuse me.
Rovers are docking. Excuse me.
I think you haven't shared your screen.
Oh no, I thought I was sharing. You've been missing everything. Hold on a second. It's not letting me do it. Oh, that's weird. Okay, it's not letting me share my screen, but I think it's letting me share. Can you see now?
Yes.
Okay, I'm going to repeat some things. You heard me talk about the idea of using the propellant tank. This is the SLS Space Launch System propellant tank. Turning it on its side to use as a habitat, the lower deck, the private area, the mid deck, where you're doing all of your work. And I know I'm just flashing through this. And the upper deck, which is your social deck, your group function, so your galley, your wardroom, your medical station, your command station, vehicle subsystems. And then fitting all that into a base camp, you've got the habitat with the logistics modules docked to it. You see two of them, one at the bottom of the screen and one at the right of the screen. An airlock system, which you see on the left side of the screen, and to the top of the screen, you see a rover departing from the opposite side of the common hab, which is where it was docked previously. If you look at the logistics module on the right side, you can see what the module that's got the lights on it, those are logistics modules. If you look at the logistics module on the right, you can see it neck down to a smaller cylinder that's connecting the common habitat to the logistics module. That's this multi-gravity active-active mating adapter that I was just getting to talk about. And the concern I had was that when rovers in particular dock, they're not going to be necessarily going to be on level terrain. They may be off in the field somewhere and they're on the side of a mountain. So I need to be able to accept different angles between the two vehicles. Also, one idea in the future might be an artificial gravity spacecraft. We have multiple modules that are docked together in the form of a circle. So again, you've got an angular offset between the different elements. So for my docking system, I wanted it to use sort of a Stewart platform or a double Stewart platform where each Stewart platform can adjust up to 15 degrees. That lets the total docking adapter accept a 30-degree offset in any axis, roll, pitch, or yaw. So that was the basic idea. Those ideas presented me with several different problems. Remember I said before that the common hab has to be used in any gravity environment. So I need a restraint mobility aid system that works no matter what the gravity is. On the space station, we use handrails everywhere. So you see even on the floor, there are handrails. But if I put that down on the surface of the moon or Mars, those handrails then present a trip hazard. So I can't do that. Another problem is that habitat is huge. How do I get it off of a lander? And oops, got a typo there. And then once I get the system on the surface and they're all docked together, how do I deal with the fact that the docking tunnels are going to be offset from each other? So that gave rise to several different problems that I then turned to the world to see if anyone could help me. And I'm going to switch sharing to the internet so that you can see some of the things that I turned to. Let me switch my sharing now. And I am now going to share a web page. Oh, I've got to do it one tab at a time.
Oh, you're on mute now. Nope, you've muted yourself. Did you maybe type it to him? Ah, there we go.
Okay. Somehow when I switched to share the internet browser, it switched to it made the internet, gave the internet browser the audio, but I don't have any audio on the internet, so I don't need to share that. Okay, are you seeing the screen, the internet screen now?
Yes.
Okay, excellent. So this challenge was asking them how can we develop a restraint mobility aid system that works in any gravity? And you see 101 people entered. It was, if I remember correctly, 35 countries, all six inhabited continents participated. And looking at the results, and we won't go through in detail, but there were 5 first place winners. They had developed different concepts of what they thought the system might be. And while I couldn't use any of them exactly, and I'm gonna try to see if I can click on one of them just so you can see some ideas, I was able to take different pieces of them. Let's see if this will show up. Yeah. One of the things I really liked in this concept, they have a ladder system. So they're looking at a ladder, and you can see the ladder in this image. If you look at the second one, the ladder retracts and actually formed a floor. So when you're not trying to move between different decks, you don't have a stair system that's in your way. Let me go back and I'm going to look at some of the others. The Gecko feet shoes, their idea, they looked at something that the Jet Propulsion Lab developed about a decade ago. The JPL lab was trying to do robotic servicing with satellites that didn't have the means to be serviced. So they looked at the Gecko and found a way to replicate the motion of the Gecko. And they built manipulators that have those artificial Gecko grippers on them. And they just touch the side of a satellite and it'll stick. So I thought that was an interesting idea. Another one on this one, I don't remember if he has a good picture, sort of has a picture. Basically has a elevator platform that integrated with the ladder. So that combined ladder and elevator into a single function. So these 5 projects all had different ideas that helped me to move forward with that particular project. The second issue was offloading, and I think I need to stop sharing and reshare so you can see that one. Give me a second. Hang on just a second. Okay. Okay, now I know how to do it. I can share and I can unmute at the same time. So this was a different platform. One of the groups at Johnson Space Center, we call them employee resource groups. There's a group named Emerge, and they hold a hackathon every year that they invite the public to take part in. So I submitted a challenge to their hackathon the year before last, to look at the issue of how do we get the common habitat off of a lander. It's so big that I looked at the Starship lander as a way, SpaceX Starship as a way to get it to the moon, but it's sitting at the top of that Starship. It's like 30 meters above the surface. So I asked them to look at how would they get it down. And this team, the one that won the challenge, I'll show their video in a second, they brainstormed, they looked at the issue, they came up with an idea where they wanted to look at, can we develop basically a folding crane system that would first create a counterweight. Then once you've got the counterweight in place, basically they took the nose cone, lowered it down to the surface, used earth moving equipment to fill the nose cone with lunar regolith, creating a weight. Then they deployed a second crane that would translate the common habitat out from inside the Starship. That crane would lower it and rotate it to set it on the ground. Just some more pictures of the design team. And I'll show an animation that they created of the process. And of course, they only had really 2 days to work on this. So it was a really quick turnaround, kind of like what you guys are doing. So it's not a perfect CAD model, but it gets the idea across of the general thinking that they were working on. And again, that idea is not perfect, but it gives me something to start to work with. The third challenge that I used dealt with the active-active mating adapter, and I'm about to share that screen. Faster, getting everything shared. So again, I talked about the adapter itself and how it has to accommodate the different gravity environments. 56 people entered from 20 countries, and again, it was 6 continents. And I want to show some of these entries because they're kind of interesting. So the first place idea, they have an animation here that I'm going to try to find. But basically, they used a series of telescoping rods and used them together to form a floor. Yeah, here's an animation showing it in motion. So each of the rods was individually articulated, so they could telescope in and out as the one end of the adapter bulkhead would move and roll, pitch, and yaw. They'd also give it the advantage that they could compress or extend the entire docking system if you were at no angular offset. Second place was really similar. The main difference between the first and second place is one used rectangular rods, the other used circular rods. I think this one's got it. Oh, maybe that first one was the animation. There's an animation of that one, but I don't think they put it in there on their online version. But it's the same concept, but they use circular tubing instead of rectangular tubing. Third place sort of did a similar but different approach. They looked at non-telescoping tubing, but they oriented it parallel to the hatch instead of perpendicular. The structure that these slats were on was what would telescope and what would adjust in motion. Yeah, that they don't have a good animation here that you can look at, but you can kind of get a sense of how it moves to accommodate the different angular offsets. It's slowly loading. It's not loading well, but if you look at the bottom, let me see if I can. For some reason, that one's not loading well. But if you look at the small image in the bottom, you can see how they have a similar approach to the first place, just with larger sets of beams. They telescope in the same fashion as the first place winner. The fifth place was kind of interesting to me. I don't think they have a good image of it, or not a good animation of it. Their idea, I think was really interesting, but it needs a little bit more work to be practical. Right now, there are a lot of holes in their floor. They basically designed a series of these compressible cells. So if you look at the triangular members, each of those are compressible. So the entire system can articulate, and it lets it flex and bend almost as if it was a continuous surface. The problem is each of those triangular systems is an open hole, so there's a lot of room for things to fall through. But I think there might be some ways with something like a flexible, small material, expandable material that could cover each of those holes, and we might get something approximating continuous surface. So I think there's a lot of potential in that one, even though it didn't actually win the competition. Those ideas all basically gave me ideas that I could work with to come together to create a system that will actually work. I keep seeing my presentation now. And so I want to talk about your Designathon. The challenges that you're putting together, they most likely won't be systems that NASA will then take and fly, but there will be systems that we can think about. But they're going to be, I think, even more important for you as a personal skills development. One, it's taking things that you've learned in class and you're having an opportunity to apply them, bring it all together, your engineering, your math, even your social skills. A lot of times engineers forget that the social sciences matter when it comes to spaceflight. And the reason is we don't exist in a vacuum. We're in a, if it's commercial spaceflight, it's a company that has to turn a profit. If it's government spaceflight, it's part of the executive branch of government that has to, one, execute the plans of the executive office, but two, fall within the guidelines set by Congress. So there are stakeholders no matter where you're designing. And understanding political science, understanding sociology, helps you to understand how does your space program relate to your stakeholders. Your CAD modeling skills, it's an opportunity to practice those, other design skills, electrical skills, so on. Doing a designathon helps you to bring all those together and think outside of the box of how can you use them in a way that's different from what you may have been taught. The second thing, the more obvious part, is it gives us a way to look at human spaceflight. How can we do things differently from how we're doing it today? How do we get more opportunities? How do we get more value? We're limited in mass, we're limited in budget, we're limited in volume. You're going to come up with ways to use them differently, those constraints differently from how we may have thought, and it'll give us new ideas. The third thing that's valuable is publishing. A lot of times people don't think about the importance of publishing, but going to a conference and presenting your paper, your ideas, it's extremely important, because otherwise your ideas kind of live and die with you. You do them, it's good for you. Whoever asks you to do them, it's good for them because they get to see them, but no one else knows about it. So when you go to a conference and present, it puts it in a form where other people can see. And years from now, when people are looking at a particular topic, so for instance, when they're looking at docking systems, they can go find the paper that I published on the N-Gamma, and it may give them an idea that helps them with what they're working on. It also builds your resume. So as a student, I know when I was a student, people didn't talk about it much, but it's beneficial to actually start publishing. Most of the major engineering conferences have student paper tracks. So even if you don't publish in the main track, you can publish in that track, and it goes on your resume. So if you've already presented papers by the time you're graduating, that makes you more marketable than if all you have are good grades. The good grades are critical. They're kind of like your lifeblood. You're not going to really have a chance in the industry without good grades, but you need to do things in addition to those good grades, and publishing the results of work that you do at a designathon is important. I don't know if I've taken up too much time, but if there's any time left, I would love to answer any questions you may have.
Anyone online, you'll have. I do have one question. So one of the things that we are looking, well, we're looking at two things mainly. We're looking at lunar habitats as well as the ISS. So in your experience, like when you think about the ISS, what kind of functions do you see that can be incorporated into the ISS? Since it's supposed to be decommissioned in the next couple of years. So if you can talk a little bit about that.
Sure. I have a couple different thoughts. One, because space tourism is just beginning to develop, and there is a vehicle now that can take tourists to orbit. I think something that could be a useful addition, space station was designed as a laboratory, and it's going to continue to be a laboratory right up until the last crew leaves it. But can we also do things on the station that help pave the way for increased space tourism? And that's one idea. The obvious one is a tourism module, just a place for tourists to go and play. You don't have to be a researcher to be in space. That's all we've done so far, but there are other things you can do. There could be business modules, so ways to start commercializing the things that we've learned in space. Another one that's kind of a personal for me, I love the Air and Space Museum. I used to go there when I was a kid. Every time I go to DC, I want to go if I have time. But it bothers me that we're going to deorbit the space station and burn it up. I think we ought to recover the space station and put it in a museum on Earth. So it wasn't designed for that. So something that could be added is, what could we use that could help separate the station into its original modules so that a starship or something else could come up and retrieve it pieces at a time and bring it back down to Earth? And as we disassemble it, how do we keep the rest of it, the part that's still left in orbit, how do we keep it functioning without the parts that we just took away? Like when we take the solar arrays off, how does the rest of it stay up? As we change the modules, we're changing its center of gravity. How does this attitude control system keep it flying level so it doesn't start to tumble. I think those are three ideas that just occur off the top of my head, but we've only got a few years left of it. Let's do good things with it, and let's do new things that no one thought of.
So just to follow up on that, I'm coming from a very naive background on space stations and architecture and stuff. But is there a possibility of deassembling the space station, and rather than bringing it back to Earth, would it be possible to bring it onto the lunar surface?
We actually asked that question years ago. Technically, the answer is yes, you could do it. But because we designed it specifically as a microgravity space station for low Earth orbit, almost everything on it would need to be changed. And the effort to do all of that is probably greater than the effort of just building a new spacecraft from scratch. If there was something that was wrong with our manufacturing industry where we couldn't build anymore, then we would probably look at how do you modify it. But it's not worth the expense that you'd have to go through to try to convert it. Possible, but not worth it.
Any other
Sure. So I was just curious, you were talking about in the first redesign project that you did, you had the lower deck, middle deck, and upper deck, and you had just kind of briefly mentioned that in the upper deck there was an area for the wardrobe, and I just didn't know if you could speak a little more to that. I mean, is that the clothing? Do they, change that out? What does that look like?
Yeah, we have the apparel design students too.
Okay, so I was probably a little garbled. I said wardroom. That's basically the dining area.
Oh, okay.
All of the all of the clothing is kept in their crew quarters, but there is an interesting wardrobe question that I didn't really get to. If you remember during the first crowdsourcing challenge, one of the entries was the Gecko feet shoes. We've expanded on that idea to look at a Gecko mobility aid system. So basically an entire crew clothing system where clothing items are lined with those Gecko gripper pads. So you'd have them on your knees, on your elbows, on gloves, on different types of booties, on your back. We're experimenting with that now, trying to figure out what are the best places on the body to put those pads. Don't have any funding for this, but what we need to do next at some point soon is a zero gravity flight on the zero-G aircraft to actually get some experience seeing how well does it work in a microgravity sense. That's I'm looking for funding to do that. So every time innovation funds come out, I'm going to be applying for that. But an interesting apparel question there is, what are the right types of clothes? One of the things we learned is that loose clothing doesn't work well because you need good contact between the gripper pad and your body. So it works best if the clothing is tight. So what parts of the body are both good for mobility, but also are good points to have tight clothing that's not uncomfortable? So that's kind of an interesting apparel design challenge we're working now.
Thank you.
Any other questions from our guests who are online on Zoom? Anyone here? All right, so I think there are no other questions. Thank you so much, Dr. Howard, for making time for us. So,
Oh, my pleasure.
okay.
And I'm going to be excited to see what you all come up with. I'm going to be really interested.
Great.
Thank you.
Thank you so much.
Well, have a good day. I'm about to go back to the field for desert rats. So I didn't tell you, we're in the desert now testing the pressurized rover.
Oh.
Goodbye.
Bye.